Welcome everyone. So in previous tutorials we have understand the basic concepts of Mathematica and the basic functionality of Mathematica by which you can use your code efficiently and you can work it mathematical computation basically more fast. And I remember in second tutorial we have gone through to different type of plotting and graphics. So today we are going to discuss working with matrices and use of some functions like table, solve, reduce and NSolve. So here I am Brij Mohan from Department of Mathematics, Hansraj College. So let's start it. So in Mathematica, first we define the matrices, and the way of defining it is like it. As we have already discussed about list. So list is basically one-dimensional. When we talk about one-dimensional list, means you have elements like this one, 1, 2, 3, 4, 5, 6, and so on. So if we club all the elements like in curly bracket like a set, it is called as one-dimensional list, 1D list. Or if you write elements like this one, 1, 2, 3, and 4, 5, 6, and 7, 8, 9, and like this one. So we say it's two-dimensional list. And this two-dimensional list is nothing but a matrix. So we can go to different dimension also. It's not bound to the one dimension or second dimension. You can go to the 3 dimension, 4 dimension, depending on your requirement, depending on the data what you want to use for your work. So here we are defining the first row matrix. Row matrix is nothing but is a single one-dimensional list. So we use curly bracket to create one-dimensional matrix or a list like this one. So you will define the name first. You will write a name A, and then that is an assignment operator, which is we say in mathematics equal, but in coding or programming we use it like assignment. So A, then assignment for the elements 1, 2, 7, and 9, and we will put curly bracket in the starting and end. So this is how one-dimensional list look like in Mathematica. The second point is how we can retrieve the element from this list. So for example, if we want to retrieve the element third, so the notation for retrieving the element is like this one. You will write the name of the list, then 2 times square bracket in the starting, then you will write position and 2 times square bracket close. So that is the way you retrieve the element for any list what you have created with some name. So here the name for the list is A. So I will write A 2 times square bracket, then my position is 3, and the 2 times square bracket close. So it will retrieve the element of this list at third position, so which is nothing but element 7. So the output will be like 7. So remember, in Mathematica, whatever we are working, everything is stored in matrices. As we have already seen the plotting or something, if you want to put in some range for plotting, that is also in curly bracket. If the answer for some solve is coming, that answer will come also in the curly bracket way with some rule. So we will come to that point also when we will understand the function solve. So in the next slide, we have two-dimensional list or a matrix. So two-dimensional list or matrix. So we use multiple rows with curly bracket to create a two-dimensional matrix or list. So how we will do it? We will do it like this one, that first row means one-dimensional list, then comma, then second row as in a second one-dimensional list, then comma, then third row as third one-dimensional list. So and you will put all the one-dimensional list in one-dimensional list. So one-dimensional list inside a one dimensional will create a two dimensional list. So here you can see example. So my list name is B and the first row is 1, 2 and 3 and it is inside one dimensional list data. So that is curly bracket here, here 1, 2, 3, then comma, then second row, then comma, then third row and another curly bracket will come here. So that is how we create two dimensional list or a matrix. Also the answer, if we will execute this command only without the semicolon, the answer will be look like the same because matrices store everything in list. And that's why if you want to see your output, the matrix output in the matrix form, what we do in mathematics in general, so you will use command matrix form M capital, F capital, as same as we have discussed already, the rule for writing a Mathematica built-in function. So every word should start with a capital letter and that's why matrix form M capital, F capital is there and you will put the name inside the square bracket B. So output will look like this one. So this is output of a two-dimensional list but in matrix form. Okay, now come to the point again how we will retrieve the element of two-dimensional list. So you will do the same 2 times curly bracket, 2 times square bracket and inside this one you will put the position of row, comma and position of column. So this is how you will write your input B, the list name, the 2 times square bracket, then ith position, that means rowth position, that is 2 and column position, that is 3. So second row and third column the element is 6, so output will be 6. So this is the way you will define the retrieving some element for your matrix. Okay, now come to the matrix operations. So in Mathematica, doing mathematics operation such as addition, subtraction, multiplication and division, the same we apply in matrices. So here you can see if you want to add two matrices, these are two-dimensional two matrices A and B, and if you want to add you just simply write A plus B and you will get your answer. And if you want to see your output as matrix form, then you will write matrix form and your previous output, as we have already understand this symbol as nothing but previous output. So this is your answer for that. If you want to subtract the matrices, then command will be A minus B and you will get your answer. The most important point in matrix is their multiplication. So there is a two way of multiplication of matrices. The first is component wise matrix multiplication or matrix multiplication row by column, that is the standard rule. So if you write A cross B and if you write A dot B, so let me clear that particular point that some students may have gone wrong using the symbol for that by multiplication. So in this symbol use, A star B is nothing but the component wise multiplication. That means if you have some matrix here 1, 2, 3, 4, let's say 1, 2, 3, 4, that is one matrix, and second matrix is let's say 1, 0, 1, 1, and you want to multiply these. But in Mathematica you used star first. So what is the meaning by the multiplication by using the star symbol or asterisk symbol? So this operator do component wise multiplication. So 1 with 1, 1 into 1 will be 1, then 2 into 0, that is 0, 3 into 1, that is 3, and 4 into 1, that is 4. So this multiplication is component wise multiplication. It is not the standard matrix multiplication if you use that particular operator asterisk. So how we will differentiate that we need our output as standard multiplication. So there is an operator dot. So this dot do work for your matrix multiplication. So here is A dot B, and this is nothing but your matrix multiplication in standard. That means row by column. In matrices you use row by column. So remember, never use A asterisk B if you want to use matrix multiplication in standard. Always use A dot B. Now come to the another example. For example, you have 3-dimensional list A, or oh no, it's a 2-dimensional list but with 3 by 3. So that is 2-dimensional list 3 cross 3. Then B, again 2-dimensional list with 3 cross 3, and the matrix multiplication A dot B will give you answer like this one in matrix form. Okay, another matrix operations you can define in Mathematica directly, and all these functions are built-in function in Mathematica. The first one is transpose. So if you want to find out the transpose of mathematic matrix, so you just write transpose, and you will give input as A. So transpose of A will be look like this one. So this may be change in output because this output is in matrix form. If you get output in your curly brackets, then you have to write matrix form. Another is inverse. So finding the inverse of a given matrix A, you just need to write inverse I should be capital, like T capital in transpose. Then inverse of A will give you output like this one. Then you can find out also the determinant. So to get the determinant for a matrix A, you just write to det. It's not the complete name but DET only. So remember this one, det for determinant, then you will get your answer. And you can find out the trace also. So to finding the trace of a matrix A, you just need to write TR, and the T is capital. So TR is stand for trace here. So all these are built-in function, and you can easily find out the values for these built-in functions. Another matrix operations are, for example, matrix power. So if you want to find out some power for a particular matrix, then you can use the matrix power built-in function. P is capital, M is capital. So matrix power of some matrix A, and you have to give the number, the how many powers you want to find out. So A comma 3 will be the argument for your matrix power function, and you will get this output. And also remember, it is A dot A dot A. So you can also find out matrix power if you want to do matrix multiplication, as we have discussed in the previous slide, that dot product is used for matrix multiplication. So A dot A, that is A square, then again A, it will give you A to the power 3. So you can find out by this command also. So always remember, so it is not A to the power 3. If you will write A to the power 3, A to the power 3 directly, and you want to execute this, so it will give you A star A star A. So I hope now you are clear by using the operator asterisk or dot. So dot give you the standard multiplication, and this give you the component wise matrix multiplication. The next is identity matrix. If you want to create some identity matrix of order n, so you just need to write order as an input for this function identity matrix, I capital, M capital, and you will get identity matrix. That means 1 1 1 on your diagonal element position. Another function is diagonal matrix. So if you want to create some diagonal matrix with some elements, so you just need to pass the elements by creating list for that. So don't write elements directly here 1 comma 2 comma 3, but you have to put 1 comma 2 comma 3 all the elements in your curly bracket. So you just need to first pick a list and then pass that particular list to this function diagonal matrix, then elements will go to the diagonal position and you will get your diagonal matrix. Another function is dimension. If you want to find out the dimension for a particular matrix, so the command is dimensions. D is capital and you will put your matrix name inside it and you will get the dimension. So A is 3 by 3 matrix. So last working example was A 3 cross 3 and that's why the answer is 3 cross 3. Okay, now come to the function, table function. So I have picked some very useful functions like table, solve, NDSolve and reduce. So I will go to all these functions one by one. Let's understand the first function, table. So what a table do? Table generates a list of the values for given range. So in table you will define a function and you will give some range, then for that particular range apply on that function, this will create a list. For example, here the table function is there, I have written here I square and the range for I is 1 to 10. So it will go I square, the first for I is equal to 1, then I is equal to 2, then I is equal to 3, like this one it will go to I is equal to 10. So for I is equal to 1 the value is 1, for 2 it is value is 4, then 9, then 16 and so on, it will go to 100 and you will put all the elements in your list. So that is how table function works. So it create a list for you. So we use this function very rigorously in our coding or programming depending on our working. So I hope it is clear to you that table function is to create a list for a function with some range. So this is the answer for the first example. If you want to use I square and range is from 1 to 10, the values will be in list, first one dimension list. So 1, 4, 9 up to 100. Another example you can see, we have function a plus b and the range for a is 1 to 3 and the range for b is 1 to 5. So it will create for this particular range to a plus b and this is how you will get. So it will create a two-dimensional list because here are two variables. So it will go from a 1 to 3, then this will go for each b, that means 1, 2, 3, 4, 5. So for this one for first one time, for complete this one for second time, for third time, fourth time and fifth time, and that is how it will work. So here 1, 2, 3, 4, 5, you can see here b 1, 2, 3, 4, 5 and a is 1 to 3. So that means 5 one time, 1 to 5 for a is equal to 2 and 1 to 5 for a is equal to 3, and you will get a two-dimensional list here. Another example is table, that you can create a list for your graphics also. So here you can see I am putting inside this table function my plot function. So plot sine of x to the power n, and range for x is 0 to 5, but this n also have some range. So n is 1 to 2, that means two plots will be there for x to the power 1 and x to the power 2 for sine. So you will get two plots first and you will put, just because of table you are using, you will put all the graphics in your list. So it's not necessary that you have to list the elements only, you can list the graphs also. Now come to the another function, solve. So solve the equation or system of equation. If you are going to use the solve function, so solve function do that you can solve system of equation or a single equation or inequalities by using this solve function. S is capital in it. Let's go with one example first. Solve, and here is one equation, x square minus 5x plus 6 is equal to 0, and you have to give the syntax, that means for which variable you want to solve. So solve equation, then comma the variables. So here is only one variable, so I will write just equation comma one variable, that is our x. The answer will be x minus x is equal to 2 and x is equal to 3. And as I have already said that everything is coming as an output in Mathematica, it comes in the form of list. So that's why you can see here it is two-dimensional list in which x tending to or x tending to 3 giving you the values for x is equal to 2 and x is equal to 3. And because the notation is tending to represent the rule, so this is named as rule in Mathematica. As in our general practice, in general life, we use x is equal to 2 and x is equal to 3. But in Mathematica, you use rule. So this one is called as rule. Okay, now come to the another example. Solve a plus b is equal to 3 is equal to means you have to use equal to operator, that is two time assignment operator. And because you have to satisfy both the equation, if you are using the set of equations, so that's why you will use AND operator. AND is your logical operator. That means if we get some values for a and b, first equation should be satisfied and second equation should also be satisfied. And that's why first equation and second equation. Or another way is also there. You can write these two equations in curly bracket also. For example, equation 1 comma equation 2. So this also works. If you want to use curly bracket only, then you have to put equation 1, equation 2 in your curly bracket. That also works. Or you can give equation 1 and operator equation 2 without curly bracket. That is also good. So that's your choice how you want to give your input as a set of equation for that. And here are two variables. That's why variables will be in curly bracket, because there are more than one variables. That's why curly bracket a comma b will be the total number of variables here, and then you will solve these two equations and you will get values a as 2 and b as 1. Another example you can see here, x square plus y square is equal to 1 and x plus y equal to a. So for x and y you want to solve these two equations. So I will write my variables in curly brackets x and y, and that's why by solving with solve you get the answer like this. Now come to the another function, and that is reduce. So reduce function reduces the statement. Reduce function reduces the statement by solving equation or inequalities for variables and eliminating quantifiers. So quantifier means when you get your output like this one. Here you can understand in the first example, let's say you are using the solve function, right? And the equation are x square plus y is equal to 10 and x is greater than 0 and y is greater than 0, and you want to solve this equation for the variables x and y. So you will get y conditional expression. Something will look like conditional expression. Depending on the condition you will get some answer 10 minus x square, and range for x is 0 to root 10. But that is not the good choice to getting some answer from Mathematica in some quantifiers. So what we will use, we use reduce in place of solve function. So we don't use solve function for this type of answer. We replace it by reduce. Now you can see the difference between solve and reduce. The output will be look like this one. So reduce the same set of equations with variables x and y, then you will get range first and y is equal to 10 minus x square. So here you have direct answer for x and y, and you don't have such type of quantifiers in it. So that's how you use reduce function. Come to the another example. For the same reduce function, let's say you have reduced x square minus y cube is equal to 1 for the variable xy. You get the answer like this one. Here we are getting OR operator, that is nothing but OR operator. So that means you can pick the value for y, this one or this one or this one, all the values will satisfy this equation. That is the meaning. Another example, reduce x square plus y square less than 1, strictly less than 1, and you want to solve for x and y, then you will get this answer. Another example, reduce x square minus 7y square is equal to 1, and x is strictly greater than 0 and y is strictly greater than 0, and you want to solve x and y with given some domain. That means you want to pick the values from integers. So if you will choose the domain after your variable, just put a comma, then write integers or reals depending on your which domain you want to work. So here is an integers, I is capital, then you will get output like this one. C1 belongs to integers and C1 greater than equal to 1 and x is equal to something. That means you have value for x in terms of C1, and C1 is nothing but coming from your set of integers. So that is how you work with your reduce and by applying some domain. Now come to the another function, that is NSolve. So what NSolve stands and what this function do. N is for numerical and solve is for solution. So numerical solution you can find out. So NSolve function attempts to find numerical approximation to the solutions of the system of equation or inequalities for the given variables. Let's come to this one example here. For example, you want to solve, and this equation is x square x to the power 5 minus 2x plus 3 is equal to 0, and you want to solve it by the given variable in x. So your output will be look like. So here you can see that x is tending to some root value of 3 minus then 2, some value is there, then some value is there, but how much value we have, we don't know. So in some cases we get such type of situations. That means if we want to solve some equation by using the solve function, we get such type of expression, but that's not the good answer. So to coming to the correct values for this equation solution, we need to use NSolve. So NSolve basically will check numerically to find out the solution for these equations, and by using NSolve you can see the answer here is x is equal to minus 1.42361, that is real value. Another is minus 0.246 and 29 minus 1.32028 I means complex value. So that means if we were using solve function for this equation, so answer will be in some quantifiers basically with the name root, and if you are using NSolve function, then you will get your exactly solution. So that means in real or in complex. So that is why the need of this function is there. Another example are there, NSolve, and your equation is x to the power 5 minus 2x plus 3 is equal to 0, and you want to solve for reals. That means your domain is real. So you will use NSolve, then you will write your equation and you will pick the variables, then reals. Reals means your domain. So you will get answer from this domain only. So whatever you have real solution there, you will get. Another example, NSolve, and you have system of equation. As I have already said, that there is a two way to writing first equation and operator, second equation, or first equation comma second equation within a curly bracket. So that is the second way here, and you want to solve this for x and y, but in numerically, because we are using NSolve function. So you will get answer like this one. So this was our third tutorial, that how we can use matrices in Mathematica, or different functions we have seen here, like table, solve, NSolve, and reduce. So thank you everyone. Thank you so much. See you in the next tutorial.